All right, so I added an assignment 4 to our list. We have quite a few pieces to space out the kind of the points, but it's still a fairly small amount of points. So I would rather have more projects and have them not worth as much in the group. But this is kind of where it fell out with on the development. So trying not to weight it any one thing more than the other, but also want to give you enough time to ask questions, go through the process, and give you enough pointers. So unlike the pulley, my intention is not to go through every one of these sheets, but to go through high points and give you some strategies to apply the dimensions, and then see what you come up with. Ask questions on things you're not sure about. Last week we looked at some of the available resources. I think those are listed in your on the home page of Canvas, so you can refer back to those. So a couple of the strategies that I wanted to give you is I'm still not 100% on tolerance analysis, and one of the things that is still a drawback is that it's at a premium level. So there is basic level, which is pretty much parts assemblies drawings. The parts include sheet metal and weldments. And then you go up to the what was office is now professional level. And that gives you access to more capabilities, the toolbox, I'd have to look at the add-ins, about 4 or 5 more. And then when you get to the premium level, which is kind of our education version, that goes to where tolerance analysis is available. So not every company is going to have tolerance analysis. So I don't want to put a heavy emphasis on something that you may or not have access to. And then, kind of going through the process of some of those stack ups, unless you need it to generate the report or doing comparison and what if scenarios. Some of the functionality is, it's not an overall solution. So the focus is still on being able to analyze, pick out critical dimensions. So even on each of these sheets, the recommendation for this assignment for the CAM follower would be to pick some basic baseline or ordinate datums, dimension as needed, and then decide which ones are critical. Right. So mainly when we come over to the pin locations on this one, that would be a critical dimension, although they're all in line. So that kind of means that that basic dimension gets applied to everything that we pick, unless we find a way to note it. So, our process is apply the dimensions, and then after we've picked out those basic dimensions, then we pick out some datums. So you're always going to fall back on your form tolerances before we go up to positional, before we go to location, before we go to profile, and when we get to the cylindrical parts here, we haven't really covered anything that cylindrical, so I want to take the shaft and at least apply that one. All right, so recommendation, if you want to go through just in the drawing level, apply the datums, the geometric tolerances, that's fine. If you want to see what SolidWorks would generate, you can right-click on the view, and it will open up the part. The question marks mean that the multi-body part is not open currently, right? So if anything changes, there's not a back and forth handoff. So that doesn't really affect us right now. If we were making changes and it was still in that revision process, there's other things that I want to do to this CAM follower to improve the design or to make it more manufacturable, then I need to make sure that that file is open. All right, so under the DEM expert, then being able to go through, we can try an automatic dimension scheme. And so if we stayed prismatic, that would be one option. And so a primary datum would be the one that is, again, our simulator we contact. And then a second datum, we just pick one of the long edges, and a tertiary datum, I don't know that it really matters if we go left or right here, so we'll pick that as a datum, and then picking those features. So looking at it from a prismatic standpoint, it throws in the geometry. So that was a base scheme 2. And we ended up with the datums, the datum callouts, and our geometry. All right, so at that point, then we'd be going through and looking at the tolerances. The other decision you have to make is, are you going to stay in the metric dimensioning scheme, or are you switching over to inches? All right, I had a conversation earlier today about going back and forth between metric and inches, is that, you know, we're pretty much in that standard. Stay with what you're familiar with, and then make the adjustments to go over to metric if that is acting as our second language. All right, so the other one I wanted to see is if we can add a second scheme, and if it will let it go from, so it was prismatic and geometric. I wanted to see if it would add a second scheme with just the plus minus for a comparison. Okay, so it picked up the same datum and the same datum and the same datum. All right, so of interest would be, does it add anything, or, well, we got a few overall. And one of the things with these dimensions, even though they're kind of placed out into to space, we can clean those up by right-clicking on one. And if I select the annotation view and it doesn't go flying off the screen, we can switch it to the top, and that'll make it a little bit more visible. All right, so what I'm trying to get to by doing this then is to save this, go back over to the sheet, and then when we have the capability of picking model items under the annotations, the first group is dimensions that we've applied, marked for drawing, not marked for drawing, patterns, instance revolutions, tolerance dimensions, whole wizard profiles, the locations, and then the whole callout itself. The second is where we get into the dim expert annotations. So even though I've already inserted this, I can see what the geometric and the datums. We haven't really done much with datum targets. Datum targets where, you know, establish a location where we can inspect from. So if, you know, we knew that this was a wavy part or that it had some issue, we could establish 3 points to act as our primary datum and say specifically this is where you're going to contact. All right, and then the reference geometry, we haven't really generated any planes, axes, coordinate systems, origins, the center of mass. So at this point, let's go ahead and accept and see what it gives. Change import from to the entire model. Yes, entire model. No. Selected do not have dimensions. So what did I just tell it to do over here? Did I save it? Now let's make sure it's saved, because there's definitely annotations there. All right, so the entire model, import items into all views. Don't know that it was, still have those. Include items from hidden features, dimension placements, no layers. Okay, I'm gonna have to go back and look at that one. Okay, so it's not bringing them across. So the other one I want to check then is if I delete that view, and let's see if we can just drag and drop it from the view palette, since that one is open. All right, so when we import annotations, let's see if it'll bring the dim expert annotations in. And we were looking at it from the bottom, brought in 1. Okay, I'm pretty sure there was a few more than that, so I wonder if I wonder if that's to the model-based definitions. So we're going to have to explore that one a little bit more and see what's going on with it. All right, so you can use that for reference, but obviously the tolerances are a little wide open here. So I want you to think about what's going to be realistic for flatness, parallelism, the perpendicularities, the positional callouts, and again the pen locations and the pen sizes for a light press are going to be our critical dimensions. For the other two, I think we covered if you want to rotate this, go to a different view and kind of position it a little better if you pick the view and hit rotate. If you've already added dimensions, you don't really want to do that because it'll wipe out all your dimensions. We're going to throw some flatness and perpendicularity, and also, even though it's not really required, we'll put an angle tolerance zone on that one just because we can. Probably some position, some flatness. Again, the top doesn't really perform any major functions, so parallelism would be optional. But we need the positional for our counterbores. And then we get to the bearing. Let's see, did we give that a full name? For the bearing housing. And so we want to look at having either positional tolerances for the two bearing faces, bearing cylinders, or we'd want to look at having run out where the first becomes a datum A, the second becomes a datum B, and then the rest of the geometry is in reference to the face, and then potentially the lead face would be a datum C. So that would give us a couple to work with. All right, so the one I really wanted to do is the shaft, and so when we're looking at this one for tolerances, the M16 by 2 thread, not exactly what I would expect to see, but it does pick up the notation, and then that should be our cosmetic thread. So that should be looking down through this, one of these should actually be that thread. So when we go to apply a few more dimensions, let's see, so if we go to the critical, let's see if it'll just pick that one up. So 630, that is the M16 by 2 then. But it's not really giving me a lot of information, and it's taking up space, so I think I'm going to eliminate the left side view so that we can talk about the critical dimensions. All right, so when we go into the smart dimension, I'm going to stay with the front view, and with the 630. We're going to start to control some of these, so this is probably going to need to be a basic dimension so that we can start to look at it with as a datum. And so when I apply the datum feature, label A, and would prefer to have it, okay, it can go there. I want to see if it would drop it to the, nope. It really doesn't want to do that one. Oh, there it is. No, filled triangle. I'm going to say maybe it's giving me vertical. There it goes. All right, so, but it didn't stay with it. That's nice. Okay, not quite what I'm expecting it to do. Probably should have just left it at the beginning. All right, so we have the 630. I was trying to get it to do that nice little drop it down flag from the dimension. So All right, so if that's our A, and then, oh, that was the one thing that showed up on the end view that we called out was the center drill. So this one probably will go to hidden lines visible, so that we can kind of see that. Sort of makes it a little busier around the cosmetic thread, and definitely a lot busier over here. So what I would like to see then is if A is our central axis or axis of revolution, then I can pull out the run out between those geometries. All right, so the next datum, if we pulled up another datum feature, would be to go to the face. All right, so the main concern, or the main reason for pulling that geometry, will be that we've started with the axis, and then I want to be perpendicular to that axis. Right, so the B, if we're going to pull up a geometric tolerance, then I would want to show something like perpendicularity, and probably within 2 thousandths, and the datum would be A. So we have that flag. All right, and then the run out could be in relation to both datum A and B. All right, so as we go through and we start to apply these dimensions, then it's always kind of a toss-up. Do I switch over to cylindricity and pick one of these, or do I just stay with the run out? So the thing with the run out, it's at a cross section where the total indicator run out is across the whole surface. So measuring both concentricity and its relation to the datums. All right, so if we were to put a value, and actually I think since this is adding them pretty easily, I'll go ahead. So the one thing with the machine threads, not really critical. I mean, they don't want them to be crazy on the run out, but we want them to to have that float. The thread relief, then same thing, not so critical. All right, so the actual surface then, we went 2 thousandths for perpendicularity. Let's kind of stay in that range. And the primary will be A, and the secondary will be B. Okay. And then I can double click again. A for the primary, B for the secondary. Okay, so what that does for me, hopefully, is we establish that in our geometry that this is the critical dimension. On the downside, if I'm looking at this from a manufacturing standpoint, I've kind of done this backwards. The issue is that when I'm holding onto this, I'm probably going to have a large piece of stock that I'm going to be able to machine all of this geometry off of the left side. And even though I'm really focused, I want to control this end dimension, because that's what that big honking chunk of cam is rotating around. What's taking all of the load. It's not really my best datum. All right, the other side that connects to the motor is probably a more appropriate, or we go over to the geometry that is actually going to ride on the bearings. All right, so if I'm looking at it from that standpoint, then the 630 becomes a basic dimension, and we're going to end up going over to the outside face, and I need to change that back over to A. Alright, so as we go through this, then the smart dimensions, we have the call out, and we'd have to determine, is that going to be a for reference, or is that going to be the actual call out for our geometry. So if we come over here, and I need to switch that around so it's interior, we'll go ahead and place these. And so I need to grab that one. And starting to run out of room, so we'll see how far we can take this. Okay, so that gets us over to the geometry. All right, and since this all of a sudden became A, then we have run out for the surface, and I have to go back and look this one up because that one still kind of throws me that, in a sense, this is taking the place of our concentricity. So it can act as a form tolerance. I believe it can act as a form tolerance. And then if I'm also putting it in relation to B, I can have a second primary that it has to, that they have to be related to each other. No, I think that one takes care of that one. All right, so this is where the thought process has to go through. Oh, took that one off. Well, that's an interesting way to do it. Okay, I didn't know it would do that. All right. All right, so the other key interest is if we wanted to take it far, I think it's about as easy to have the run out across this entire surface. Otherwise, we could give it the ½ inch or so that's going to contact the bearing, the ½ inch on this end that's going to contact the bearing, and say that the run out is from this distance to this distance. All right, since we're not talking about like an extreme amount of length, I want to say we'll just kind of leave it and come back to that one later. And are you going to let me put it somewhere else? No? Okay. So what I'm trying to do is open up room, since we're going to get a little snug here. All right. So at this point, we're not really say it's going to be a little more difficult to figure out which ones are which. So at this point, I may want to drag or attach the reference to the dimension. So since that one's being affected, that one's being affected, and lastly, those are all of the basic dimensions. Let's see if we can clean this up a little bit. All right, because I still have to get the lengths in here. And so I think this is somewhere that the ISO standard does better, is with these showing up vertical on the diameters. It is a little more helpful, but fit in there. So let's see, we need a chamfer since it's here. So right click. If we go to the more dimensions, I should have a chamfer. And I always forget if I need to pick the face first or the chamfer first. So obviously it was the chamfer first. All right, so 20 thousandths by 45. The downside to chamfers is that we're not going to hold that to 3 decimal places. So we'll go up to 2 decimal places. And if I wanted, we could go ahead and put in the 2 times dimension. so that it has both ends. And then that covers the chamfers on each face. And then I mentioned that we can put in either a reference or a notation that says the center drill is optional if it helps with manufacturing. Basically because the other end ends up with the drill and tapped, they could put the center drill in there for the manufacturing process, drill the hole afterwards, and it would be, you wouldn't even never know it was there. So that being the case, then we have our references, and then the last one would be the position. So the axis of A, and then I really want to kind of shift that over to ordinance just because it's already getting kind of busy. So with an ordinate dimension, we set our 0, we start at the ends, and as I go through the vertical lengths, then we're going to be able to pull that geometry. Alright, so now it's a matter of positioning where everything is hopefully not going to be too big of a mess. Alright, so that will require a little bit. Oh, and that was the last dimension too, was on the outside. So said that one's not going to be a critical. So I'm just going to go to the OD, and really that's just going to contact the bearing race or similar. So let's see if I can find a spot where it doesn't get off of the border. All right. So getting a little more busy, and then the last one will be that you can pull up the dimension for the width of the keyway, which we said was going to be a little over 5 millimeters. Oh, and that picked the cosmetic thread, so that wasn't it. The cosmetic thread, and then this gets a positional. So we'll place a basic dimension. Let's see if we can go in with a positional tolerance. Well, let's stay with the 2 thousandths. On the low side, there would be 1 thousandths clearance. On the high side, there would be 5 thousandths, just off the top of my head. So position to A, and then, well, let's go with that one for now. Okay, and then the last one was the position for the depth, and then that one always looks a little interesting. So let's go with a reference, and if I hold down the shift button, it's going to give me that one. No. See if I can find that diameter. All right. So 106 from the top, that doesn't really give me the type of dimension, tolerance dimension. That would be more of a manufacturing dimension, I would think, for a reference. So this one can get parentheses, and then the dimension that we actually want to produce is probably going to be from the base to the bottom, and really we're not that capable of measuring or coming up with a number for that one. So let's see if we tuck that one in there. So if we were measuring off of the bottom over, I could get a dimension. That would be another one that's up for review. All right, so it gets pretty busy pretty quick, but as a first pass, this gets us all of the critical dimensions that are being affected by the bearing and the geometry. All right, so let's see, what was the other ones? Then the cam was thinking that this would be a surface of profile, even though it is circular. If we were to modify this cam, then we would have additional geometry and positional tolerance for the keyway. Pretty much the pins to press through, so the through hole through both faces will need to have alignment. And then the last one was to bring up the spherical radius. So there's not anything really critical here. I would think that we could precision ground shaft concentricity within a couple thousandths and size to fit inside of the bushing would be fine. So the one thing I wanted to throw out is the notation that when we place the dimension, whether we're putting it into the actual dimension or we need to pick up the symbol, then we can look down through here and let's see, that's the controlled continuous. All right, not seeing it. Oh, spherical diameter. All right, so I was thinking spherical radius, but that gives us the spherical diameter. Or if we apply the dimension and it goes to the radius, I should be able to switch it over to diameter. And when we come down to its modifier, then pretty much the same thing. So if I go over to the, well, basically it's the center line symbol, and pick up the spherical diameter, then that at least does the call out to where it has the notation that it is all around. All right. So make a pass on these. Come next week with questions or shoot me emails, and we'll get this project underway.